Thank you, and thank you for coming. Just briefly, I wanted to let you know that my interest in this topic is both professional and personal. I was first introduced to ayahuasca back in 1987. During a trip to Ecuador, we were working with shamans, and I met my future wife just before an ayahuasca session and changed my life in some very significant ways, including my two children who are now here, my two youngest children. Also, about 3 years ago, I think it was, I traveled to Ecuador with my oldest son, who's now 22, who was experiencing substance abuse problems with alcohol and marijuana and was getting into a lot of trouble. And fortunately, we have a friend who's a shaman from Ecuador who now lives in Santa Fe, New Mexico, and he had suggested that we travel to Ecuador to drink ayahuasca that would help him with his substance abuse problem. So trusting this gentleman very, very much, we traveled to Ecuador and drank ayahuasca under the tutelage of an older shaman friend of his who'd been drinking ayahuasca daily for over 50 years in the Rio Napo region of Ecuador. And since then, my son has, it was not an instant cure, but he's doing much better and not abusing substances any longer. So I have both a personal and professional interest in this topic. And along with my friend James, we decided to investigate how is it possible that this foul-tasting liquid from the Amazon could help people with addictions. And so we began studying different mechanisms to see if we could come up with some hypotheses that might be tested to better understand how this medicine might work. And in looking at this, we've come up with 4 different hypotheses, which we believe are interrelated, that may help explain how ayahuasca works. These are not independent hypotheses, but interrelated. And we've looked at how ayahuasca may work at biochemical, physiological, psychological, and transcendent levels. And that's what we'd like to present today. So I'll turn over to James for the hard parts of the talk.
So to set the stage for our first and second hypotheses, I'm going to talk a little bit about the basic biochemistry of ayahuasca and addiction. So I'll start with the biochemistry of ayahuasca. And I suspect at this point in the conference, many of you have been exposed to this material, so I'll move through this first section relatively quickly. So ayahuasca is most commonly a admixture of 2 plants, Banisteriopsis caapi from the family Malpighiaceae, which is a lot of fun to say, and Psychotria viridis from the family Rubiaceae. Banisteriopsis caapi contains beta-carboline alkaloids. There's the structure of beta-carboline there. It's an indole group connected to a pyridine ring. So Banisteriopsis contains multiple beta-carbolines, primarily harmine and harmaline, and to a lesser degree tetrahydroharmine. And you can see how closely these resemble beta-carboline. And they differ only among themselves by the location and number of double bonds of the pyridine ring, which is on the right. So what makes beta-carboline so important? They are important because they are potent monoamine oxidase inhibitors, otherwise known as MAOIs. And MAOIs prevent the breakdown of monoamines by inhibiting the enzyme that breaks them down. Some examples of monoamines, you've probably heard of many of these. The catecholamines like dopamine, norepinephrine, epinephrine. The tryptamines, serotonin, melatonin, dimethyltryptamine. And there are many other amines, traceamines, tyramine, histamine, thyronamine. And the ones in red are going to be important for our talk today. So the other plant, Psychotria viridis, contains N,N-dimethyltryptamines. Sorry about that. Psychotria viridis contains N,N-dimethyltryptamine. See the chemical structure there? It's a indole alkylamine. DMT is pretty much ubiquitous in nature, and it's even been found in human cerebral spinal fluid. And you can tell by the name, dimethyltryptamine is similar to 5-hydroxytryptamine, otherwise known as serotonin. They both have the indole group on the left, tryptamine base. And because of that similarity between dimethyltryptamine and serotonin, dimethyltryptamine works on basically all of the serotonin receptors. In particular, it has agonist action at subreceptor types 1C, 2A, and 2C. Unfortunately for us researchers, DMT is a Schedule I drug under the Controlled Substances Act of 1970 and thus has no approved medical use in the U.S. When smoked or snorted, DMT is a very potent, very short-acting medicine which causes a rapid altered state of consciousness. However, when orally ingested, it's not active because it's broken down by monoamine oxidase enzymes in the GI tract. It is active when orally ingested in the presence of an MAOI. So, when dimethyltryptamine in Psychotria viridis is combined with the monoamine oxidase inhibitors in Banisteriopsis caapi, orally active ayahuasca is formed. So, on to the biochemistry of addiction. It is an incredibly complex phenomenon. We don't really understand much about it. The brain is the most complex thing in the universe, and addiction uses a lot of parts of the brain, so we're just now starting to figure this out. So we're going to be using a pretty broad definition of addiction today that is inclusive of dependence, a complex set of behaviors that includes withdrawal, tolerance, loss of control, compulsivity, preoccupation, and continued use despite adverse consequences. Dopamine is one of the monoamines that we talked about earlier, a catecholamine. It's a neurotransmitter, and it's very strongly implicated in both the etiology and the maintenance of addictive behavior. It is associated with things like desire, motivation, salience, novelty, all surrounding pleasurable experiences like Facebook. Natural pleasures like food, sex, and for me recently, Girl Scout mango cream cookies all increase dopamine levels. Delicious. Drugs of abuse, however, increase dopamine much more than natural responses, 2 to 10 times more, in fact, than non-drug experiences. There is a mountain of research that supports the idea that elevations in dopamine in a particular brain circuit called the mesolimbic pathway contributes to the reinforcing effects of drug abuse and other addictive stimuli / behaviors. The 5 major types of addictive substances, including alcohol, nicotine, stimulants, opiates, and marijuana, are all known to increase dopamine in this pathway. So what is the mesolimbic pathway? It's often been referred to as the pleasure center or reward pathway of the brain. And as basic as it gets, it's primarily 3 brain areas: the ventral tegmental area, the nucleus accumbens, and the prefrontal cortex. The ventral tegmental area is a group of neurons in the midbrain that release dopamine when exposed to addictive drugs or even cues associated with addictive behavior. And that dopamine is communicated to the nucleus accumbens, which communicates with the prefrontal cortex. And the prefrontal cortex is one of the evolutionarily newest parts of the brain. It's associated with higher level cortical processes like personality, executive functioning, motivation, and it completes the reward circuit by communicating back to the ventral tegmental area, both directly and indirectly through another limbic structure called the amygdala. So we've been talking about elevations in dopamine in this particular brain circuit, and that's associated with reinforcement. However, acute withdrawal after chronic use of substances is in contrast associated with low dopamine levels. Doctors Michael Bauman and Richard Rothman and NIDA have proposed a very provocative model for addictions called the dual deficit model. And the premise of this model is that repeated use of drugs of abuse results in decreased levels of both dopamine and serotonin. And these deficits in these neurotransmitters are thought to contribute to withdrawal symptoms, drug craving, and the potential for relapse. The low dopamine is thought to play a role in anhedonia, psychomotor slowing, and craving associated with withdrawal. And the low serotonin is thought to basically underlie symptoms consistent with major depression, depressed mood, obsessive thoughts, suicidal ideation, impulsivity, etc. So craving may be a subjective manifestation of the brain's homeostatic drive to normalize dopamine in withdrawal. Researchers have found genetic polymorphisms for the dopamine D2 receptor, and there's two alleles, major alleles, DRD2A1 and DRD2A2. About a third of the U.S. population is hypothesized to have the A1 allele. And people with this allele have a genetically predisposed lower level of dopamine receptors and overall dopaminergic functioning. And as a result of this, they're predisposed to addictive behavior because they always want to normalize that dopamine level, that deficit, based on this principle. So in review, high dopamine in the mesolimbic dopamine pathway is associated with conditioning and reinforcement of addictive behavior. Low dopamine and low serotonin are associated with withdrawal. So therefore, an ideal biochemical treatment would be something that increases serotonin and balances or normalizes dopamine between withdrawal and reinforcement. Balance is not only the key to life, it is also the key to dopaminergic functioning. High dopamine results in reinforcement of addictive behavior, low dopamine withdrawal. So our biochemical hypothesis is that ayahuasca's anti-addictive properties result from its ability to raise global serotonin levels, in addition to acting as an agonist at particular serotonin receptors, and normalize and stabilize dopamine by what we're calling tug-of-war mechanisms. So how does it act on serotonin? Well, the monoamine oxidase inhibitors in Banisteriopsis that we talked about inhibit the enzyme that breaks down serotonin, which is a tryptamine, therefore raising global serotonin levels. DMT, as we talked about, is an agonist at multiple serotonin receptors. Ayahuasca and dopamine is a little bit more complex. This is the tug-of-war mechanism that I was talking about. So again, monoamine oxidase inhibitors are going to block the degradation of catecholamines like dopamine, just as they block the tryptamines like serotonin, resulting in elevated global levels. In addition to that, 5-HT1C agonism is known to raise dopamine in the mesolimbic pathway. In contrast to those two mechanisms, 5-HT2A and 2C agonism is known to lower dopamine in the mesolimbic pathway. So what we're hypothesizing is that these tug-of-war mechanisms result in the net effect of normalization or stabilization of dopamine above withdrawal but below reinforcement. So on to the physiology of addiction. The elevations in dopamine that we've been talking about in the mesolimbic pathway are associated with a phenomenon called synaptic plasticity. This is a process by which nerve cells, the communication and connections between nerve cells are altered or changed. And synaptic plasticity has been associated with the development and maintenance of addictive behavior. So release in dopamine in two parts of the mesolimbic pathway that we talked about, the ventral tegmental area and the nucleus accumbens, has been hypothesized to reorganize neuronal circuits leading to or reinforcing addictive behavior. And we know drugs of abuse acutely raise dopamine in both those areas. And this results in a change in neural architecture, and that's associated with conditioned and learned processes. So this process has been referred to as diabolical learning. These neuroplastic changes result in the activation of reward circuitry even when exposed to objectively neutral cues associated with addictive behavior. When I walk down the street, I don't get a dopamine push when I see a street corner. However, the heroin addict who walks by that same street and buys his heroin will get a little bit of a rush just walking by the corner. That's the diabolical learning that we're talking about. So according to Stahl, the reward pathway has been hijacked by the addiction process. And our physiological hypothesis is that ayahuasca facilitates adaptive synaptic plasticity by regulating dopamine levels and a bunch of other associated cascades in the mesolimbic pathway. things like glutamate and GABA and metabotropic second messengers, transcription factors. There's a lot that goes on behind synaptic plasticity, but dopamine does play a large role, we know. So again, balance is important. High dopamine, reward circuit hijacking. Low dopamine, a diminished impetus for neuroplasticity. This adaptive plasticity that we're talking about would allow the learning of new behaviors and associations without hijacking the circuit. And it would also, interestingly, support the unlearning of addictive associations and cues by allowing the person who's under the influence of ayahuasca to experience these cues in the visionary state while being protected from the dopaminergic surge that would lead to reinforcement or pathological learning, diabolical learning. On to the psychology of ayahuasca. I'm going to pass it over to Mitch.
So we've covered our first two hypotheses, and we're running out of time, so we're going to cover the psychological and transcendent hypotheses next. One of the ways that it's believed that ayahuasca may work is to allow access to unconscious emotional memories and issues, which allows an opportunity to heal those. So often when we have trauma, we become defended against those memories. We use our defense mechanisms to block them out. Well, ayahuasca lowers those defenses such that we can access those unconscious memories and heal trauma. In this way, it's very similar to what was referred to as psycholytic therapy back in the 1950s and 60s with LSD, in which LSD was incorporated with psychotherapy to help the healing process. Slides are off. In addition to helping heal past traumas, it has also been proposed that ayahuasca allows users to experience the consequences, the future consequences of their choices. This isn't an indigenous hypothesis, I guess, or a belief system or interpretation. My friend Raphael, who is the shaman, Raphael Yamburla, says that the reason he wanted my son to go drink ayahuasca was that he could see what would happen if he continued to drink alcohol. He would have visions. He said he would see a fork in the road, and then he could choose which path he wanted to take. And in fact, that's what my son saw. Some of you may say that was suggested. Some may say it was real. It doesn't matter. The outcome was a very positive one. So the psychological hypothesis is that ayahuasca treats addictions by helping resolve traumas, encouraging the understanding of potential outcomes of choices, and improving decision-making. Now, on to the fourth and final category, the transcendent effects of ayahuasca. During the 50s and 60s, transcendent experiences were reported with many psychedelic medicines, including LSD and mescaline. And these were sometimes referred to as psychedelic peak experiences, modeled after Abraham Maslow's theory of peak experiences. And ayahuasca also has the potential to produce transcendent experiences, as some of you in the room may have experienced yourselves. And these are known to aid in the treatment of addictions. In fact, in some models, these are the most important experiences to have if you want to overcome an addiction. As some of you may be aware, Bill Wilson, who was the founder of Alcoholics Anonymous, had a transcendent experience that did not involve ayahuasca, did not involve any medicines, but it was a very powerful experience for him, and he attributed that to his recovery from alcoholism. He later became a supporter of psychedelic medicines in the treatment of addictions. So in the 50s and 60s, LSD, was used quite commonly, quite widespread to treat alcoholism. And a recent meta-analysis published in 2002 found that LSD treatment was as effective as currently available medicines, such as disulfiram, naltrexone, and camprosate. These are also known as Antabuse, Revia, and Campril. These are medicines that doctors can prescribe today for treatment of alcoholism. We can't prescribe ayahuasca or LSD. So it was found that individuals undergoing treatment with LSD were more likely to recover from their addictions if they had a psychedelic peak experience than if they did not. So this leads to our final hypothesis, the transcendent hypothesis, which says that ayahuasca treats addictions by facilitating transcendent experiences. So in summary, we believe that ayahuasca doesn't work at any one of these levels alone, but in fact works at all these different levels as well as likely others. And that the most effective way to understand ayahuasca's efficacy is to really look at an integrative, holistic approach which considers all of these different mechanisms working together to aid in the treatment of addictions. And yet we still need more research, obviously, to understand more about these mechanisms as well as others and how they may be beneficial. And also we need to learn more about the risks of this medicine. As with any medicine, there are always potential benefits and risks. And if we ignore the risks, we can get into trouble. So we hope that there will be continuing research looking at all these different levels. Furthermore, we think it's very important, having both worked with indigenous shamans, to really rely upon and work collaboratively with indigenous healers who have much, much more experience with this medicine than those of us who are discovering it here. And there are many shamans who are willing to collaborate with us if only we're willing to listen. And so in summary, that's our presentation. I think we have just a few minutes left for some questions.
Thank you, Mitch and James. There's a microphone here if anybody would like to come up and ask a question.
Hi, thanks a lot. The changes, the neurochemical changes that you were talking about associated with the beta-carbolines and also the agonist activity of dimethyltryptamine seem like it would be very short-term situation of changing neurochemistry to help addiction. And so what would be the theory for why that would have a long-term result? Is it because of the revisiting what normally is triggers for addiction in that state and thereby like rewiring your normal triggers during the experience? Is that...
So we don't really know what the long-term biochemical effects of ayahuasca are, but so it may very well only work in the short term. But we have these 3 other hypotheses that may work long term. That's only one. So that's again to emphasize the importance of all of these together. It's not just one of these hypotheses that really helps somebody get over addiction, but all of them together. Does that make sense? Sorry, I don't know more about the long-term effects because I don't think anybody does, as far as I know.
Yeah. Thank you.
Hi, I have 2 quick questions. The first one pertains to the physiologic hypothesis, and 5-HT2A agonists in a variety of studies have been shown to increase brain-derived neurotrophic factor levels in the prefrontal cortex, and then studies with ibogaine more recently have been shown to increase glial cell-derived neurotrophic factor, specifically in the ventral tegmental area, that correlates with the changes in synaptic plasticity. And so that's the first question. Is there any research going on?
What's the question?
Is there any research going on currently to investigate whether those changes in BDNF may correlate with any positive benefits? And then the second question is...
Let me answer that one first because
Okay.
I'll forget it. Sorry.
Sure.
So yeah, BDNF there's so much research going on with BDNF right now. I don't know that any research is going on with ayahuasca and BDNF. But you bring up an excellent point. We're going to write a book chapter based on this stuff that's a little more extensive into the biochemistry and physiology, and I plan on adding some of that in there, but I don't think there's much, and I don't know much about it.
Okay, cool. And then the second question is there any reason to think that pharmahuasca combination of maclobamide and purified DMT, which would have a lot less gastrointestinal side effects, would be any less efficacious than the traditional admixture of plants?
You provide the funding and we'll figure it out.
Hi. It's been reported that both ibogaine and harmaline, potent beta-carbolines, are excitotoxic and cause cerebellar neuronal loss. One other possible mechanism for the cure of addiction is that it's been also reported that trauma in the early years or neonatal trauma causes an exuberance of connections to the cerebellum. Perhaps, and this results in adult hypersensitivity to stress. Perhaps one of the mechanisms that ibogaine and ayahuasca...
Sorry, we need a question.
I'm getting to it.
Okay.
Utilize is that they're actually pruning away this excess amount of connection in the stressed, developmentally stressed individuals, and perhaps those connections are what drive addiction to begin with. So I wonder if you have any comments about the cytotoxicity of these beta-carbolines.
No, I'm sorry, I don't know anything about that. I do know that anything is cytotoxic in excess. And I think that one of the things we talk about is there's a lot more research that needs to be done.
This is reported in the literature, and if you look up...
Sorry, we have a few more questions in just a couple minutes, so we're going to have to move on.
All right,
Thank
look
you.
it up. You'll find that it's been reported.
I think
in the literature.
thank you for your question and comment. I do think it's fascinating. I ran across a couple articles from Brazil about the neurotoxicity, but I didn't actually, since it wasn't related to what, directly related to what we were doing, I didn't look into them greatly, so I can't remember.
Hello. Thank you and congratulations. I was just wondering from one of the slides saying how ayahuasca is just as effective as anti-abuse, Vivitrol, and Revia. Is there any data behind it?
Yes, the study that we referenced there, the Krebs study, gives the data that examines the efficacy of various medications, the treatment of addictions. So if you want, we can give you that reference afterwards.
Any comment specifically about heroin addiction in your experience?
I don't know of anyone who's specifically treated heroin addiction. We've looked at addiction as a global process, and I don't know that anybody's done any studies specifically looking at ayahuasca treatment of heroin.
One of the interesting things about a study of addiction is when they first started studying addiction, they thought that heroin addicts or heroin would have a specific mechanism in the brain, and so would cocaine, and so would whatever other addiction. And they do to a certain extent. But what's really interesting is that no matter what the addiction is, it all ends up in the mesolimbic pathway. And that's why we focused on that, and that's why so much addiction research has really focused on that final common pathway.
Hi, I was wondering what happens if you drink too much ayahuasca. Can you overdose of ayahuasca?
Well, I don't know the answer. I don't know when it's tried. But in Colorado, we've had a young lady that died from drinking too much water, idiopathic water intoxication. So everything has a lethal dose. And I don't know that anybody's determined what the lethal dose of ayahuasca is, but there's something called the LD50, which is the dose at which 50% of usually mice die if they give them a high enough dose. So is it possible? Theoretically, absolutely. So I wouldn't suggest going out and drinking it like water, but I don't know if there has been determined an actual lethal dose.
Okay, that's going to have to be our last question because we're actually now on to the next speaker. So thank you, Mitch and James.